Howdy folks. So far in pre-calculus, the only thing that you have been asked to do with sine and cosine and tangent is to identify their values given certain radian measures or degree measures on the unit circle. For example, and you're probably going to want to have a unit circle in front of you for this. I'm not going to draw one on the board right now, but if you can get a unit circle out, have it as reference. I got one up here, so let's jump into this. So far, really all I've asked you is, hey, what is sine of pi over 3? Well, if you look on your unit circle, go ahead and pause or take a second. Look on your unit circle, go around on the unit circle up to pi over 3. Sine is the y value. Look at the coordinates. You got the cosine and then the sine. The x coordinate, the y coordinate. Sine is the y coordinate. Should be square root of 3 over 2, right? Okay, all right. I've asked you, hey, what is tangent of 2 pi over 3? Okay, all right, well, you're going to go around the unit circle to somewhere right about over here. And since tangent is the same thing as sine over cosine, okay, and since sine at 2 pi over 3 is square root of 3 over 2, and cosine is negative 1/2, all right, then you have to simplify this, okay? You have to use, now, basically there's a 1/2 up here and a 1/2 down here, okay? Both the 2's basically cancel in the top and the bottom, and we have the square root of 3 over negative 1, which is negative square root of 3, okay? All right, so this is the sort of thing that I've asked you to do up to this point, is simply given an angle. So here's the deal. I'm going to write it out. Given an angle, whoops, that's angle. I don't know what angle is. Given an angle, identify either sine or cosine or tangent or cotangent or cosecant or secant, right? Okay. Identify the value given an angle. So the input is the angle theta, and the output is the, let's just say the value. The function value is the function, the trig function value. Okay? Well, now what I'm asking you to do is, instead of giving you this and you giving me that, now what I'm doing is I am giving you, so now given the value of the function, identify the angle measure. We're just going backwards. That's all we're doing. So now I say, hey, there's some angle, just some angle on the unit circle, some radian measure on the unit circle where sine is the square root of 3 over 2. What is that angle measure? Now, there's a trick. There's a catch. And the catch is, look, if you look at your unit circle, you'll notice that sine is equal to square root of 3 over 2. Go ahead and look over the whole unit circle. Okay, and here's the catch, is that there's actually 2 places where sine is equal to square root of 3 over 2. Because, you know, we keep recycling the same numbers on the unit circle, right? Like with sine and cosine, we have a half, square root of 3 over 2, square root of 2 over 2, we've got 0 and 1. That's pretty much it. Sometimes they're positive, sometimes they're negative. In this case, we're dealing with a positive. But here's the thing. All of those values show up in all 3 of the quadrants. But sine and cosine are both positive in quadrant 1. Cosine is negative and sine is positive in quadrant 2. They're both negative in quadrant 3, and cosine is positive and sine is negative in quadrant 4. So here's the thing. Sine is negative, or excuse me, is positive. Sine is positive in 2 quadrants. Sine is positive in both quadrant 1 and in quadrant 2. So there's actually 2 theta angles where sine of theta, or where sine is going to be positive square root of 3 over 2. And one of them is going to be right about over here, and the other one's going to be right about over here, okay, depending on where your unit circle is. Okay, And so look on your unit circle and try to identify. Look up here, look up on this curve and over on this curve, and identify where is sine, that's the y value, where is it square root of 3 over 2? Well, it's square root of 3 over 2 when theta is pi over 3, and also when theta is 2 pi over 3. So there's actually two angles, and that's why I say give all angles. Now here's the thing. Give all angles between 0 and 2 pi, because technically, because you just learned about coterminal angles, so there's actually an infinite number of answers. If we add 2 pi to this and add 2 pi to this, we have 2 more angles where sine is equal to square root of 3 over 2. If we subtract 2 pi from this and subtract 2 pi from this, we have 2 more answers where sine of theta is equal to square root of 3 over 2. So there's actually an infinite number of answers for this problem, except when we restrict it to between 0 and 2 pi, now there's only 2 answers to the question. And you can do the same thing. So let me clarify. So what's happening here is the input is no longer theta. Theta is now the output. That's our answer. Our input is the trig function value. So in these problems, I'm giving you the numerical answer to the trig function, and you have to give me the angle measure. That's the trick here. So let's do a couple more. Let's do a couple maybe harder ones. Let's say, how about where tangent of theta is equal to 1? Let's find where tangent of theta is equal to 1. Well, we got to convert this into sine and cosine. So tangent of theta is equal to sine of theta over cosine of theta. And that's equal to 1. Now, you have to think to yourself, when, this is now a division problem, when does division equal 1? Well, division equals 1 when the top and the bottom are the same number. And now this is a positive 1. That means that the top and the bottom either have to both be positive or they have to both be negative. So, where on your unit circle are sine and cosine the exact same number? Sine and all, the exact same number. So either they're both positive and the same number, or the same magnitude, or they're both negative and the same magnitude. It happens in 2 places. Go ahead, look on your unit circle. Pause this for a second. Okay, so hopefully you've looked on your unit circle and you can see that this occurs on the unit circle up here at a pi over 4 angle, and it happens down here where both of them are negative. Remember, square root of 2 over 2 and square root of 2 over 2, negative square root of 2 and negative square root of 2 over 2, and that's at 5 pi over 4. So the answer here is theta is equal to pi over 4 and 5 pi over 4. Okay? And that's what you're supposed to do in this section. Remember, cotangent of theta is cosine over sine. Okay? Actually, I want to do one more example with you because there's one that can be kind of difficult. Cosecant, okay, is 1 over sine of theta, and then secant of theta is equal to 1 over cosecant of theta. Okay, so let's do one more. Let's do one more here. All right, let's say where is cotangent, or let's do secant. Here we go. Where is secant of theta equal to the square root of 2? So we've got to figure out. Well, secant is equal to 1 over cosine, 1 over cosine of theta, and that equals it's the square root of 2, okay? Square root of 2. Now watch this. Watch what I'm going to do here. Well, I don't want to know what 1 over cosine is. I want to know what just cosine is, because that's what's going to help me, is if I know what cosine is. So I am going to flip this over. So I'm going to put cosine of theta over 1. Well, if I flip this over, I have to flip this one over too. This one becomes 1 over the square root of 2. Now, cosine over 1 is just cosine. Well, this is now has a radical in the denominator, so we need to rationalize the denominator. So I'm going to do the square root of 2 over the square root of 2. And now square root of 2 times 1 is the square root of 2. And square root of 2 times square root of 2 is 2. And so, where is cosine of theta? This is the same thing as asking where is cosine of theta equal to the square root of 2 over 2. Well, that's two places. Pi over 4, right? And in the fourth quadrant, so pi over 4, and then in the fourth quadrant at 7 pi over 4. Okay? And so, that's a way that you can do secant. Another kind of tough one is, let's say that we have where is cotangent of theta equal to the square root of 3. Okay, well, this one's a little tougher. So cotangent is cosine of theta over sine of theta, right? And that's going to be equal to square root of 3. Let's just say square root of 3 over 1. Because this is a fraction, I want this to be a fraction. All right, so do these numbers look familiar, the square root of 3 and this square root of 3 and 1? When you see a cosine and a sine, and you see a square root of 3 and a 1, what do you normally see with them? It's usually not square root of 3 and 1, isn't it? Look on your unit circle and see if you can find an x and a y value that have a square root of 3 in one of them and a 1 in the other one, right? Okay, so what you probably found was the coordinate square root of 3 over 2 and 1/2, right? Where this is cosine and this is sine. This is cosine and this is sine. Yeah, they're just missing an over 2. So what we got to do here is we got to multiply by 1/2 over 1/2. You don't have to actually do this on paper. I'm just telling you how it works out mathematically. Square root of 3 times 1/2 is the square root of 3 over 2 over 1 times 1/2 is 1/2. So now cosine is square root of 3 over 2, and sine is 1/2. Well, where does that happen? Well, you can find it on your unit circle, okay? Now, here's the other thing. I want you to notice something. Now, this only happens in one place on the unit circle, but most of these have two answers. Well, the reason they have two answers is, wouldn't we get a positive square root of 3 if they were negative? What if it was negative square root of 3 over 2 and negative 1/2? It would still be the same thing. A negative times a negative is a positive. The 1/2s would cancel, and it would still be the square root of 3. And that happens in another place on the unit circle. So look and see if you can find that place. Okay? So I hope this helped you a little bit on how to do problems like that when you're given the answer and you have to find out the radian angle. Also, make sure that you're able to turn those radian angles. So like if your answer here was pi over 6, maybe it's not pi over 6, but it might be pi over 6. If your answer was pi over 6, you would have to then also be able to turn that into degrees. And the way you turn any radian into degrees is you multiply by 180 over pi. That'll cancel the pi's. 180 divided by 6 is 30, so that's 30 degrees. Okay? Again, hope this helps. Let me know if you have any questions.